Welcome back to AP Statistics with Mr. Walton. Today we're going to go over our Chapter 11 review. It's all about chi-square. So, if you look over the target issues that we have, these are the main focus groups, according to the authors of your book, that we need to say, do we know this? Do we sort of know this? Do we really need to look at this? So, let's look as we move further into this and say, let's make a decision. Am I shaky? That's what we really want to know. If you are, how about doing one of these things? Read the section summaries. How about read the chapter summary? Ask a friend for help. Shocker, shocker. Oops, that's supposed to say 4, right? And worst case scenario, ask your teacher. Yes, that's right. Some of us will actually help you. All right, so if we're looking at some multiple choice, please make sure you read carefully to find out, do I understand what's being asked? So in this case, we have a lot of information in number 1, and all they really want to know is, how many degrees of freedoms do we have? Ooh. So we need to say, we have just observed, we have just expected. That means this is goodness of fit, which means df is equal to k minus 1. So therefore I have 4 minus 1, not 3, sorry. 4 minus 1, which is 3. So we're picking A. Sticking with the same information, which of the following is the component? Remember, the component is our O minus E squared over E value that correlates with at most negative 2. So if we look at most negative 2, scroll back up, we're talking here. All right? So we're talking about our totals for the row, totals for the column, over our total. So if we're looking at that carefully, that's going to give us that beautiful expected count, right? But we already have it. Oh, Mr. Walton, what are you doing? So then what do we need to do? We just need to say, hey, I have observed, I have expected. Just plug it in. Don't make it more complicated. Again, read carefully. So if that's the case, I have 18, 25. My expected is 25, so I have 18 minus 25 over 25, so hopefully that's D. Number 3, which of the following statements is true of chi-squared distributions? Be careful of number E. All of the above are true. Alright, so as the number of degrees of freedom increases, their density curves look less and less like a normal curve. What the heck? They don't ever look like a normal curve. That means this one's wrong. That means this one's wrong. Their density curves are skewed to the left. I don't think so. Nope. Don't do that. As the number of degrees of freedom increases, their density curves look more and more like a uniform distribution? No. They take on only positive values. Yes. Their counting values are only positive, so we better pick D. Moving on to number 4. Okay, again, we're looking at grades, distributions, and hopefully we're thinking about which of the conditions must be met. All expected counts are approximately equal. Nope, I don't like that one. Each observation was randomly selected. Ooh, randomly selected. All observed counts are greater than 5. Haha, not this. No. The number of categories is small. Never talked about that. The distribution of grades in all statistics courses must be approximately normal. Not in chi-squared. Therefore, we're going to stick with D. Which of the following expressions represents the expected count of the grade category D? So that means we'll flap back up. There we go. Grade category D. What are my expected counts? Well, I expect to have 10% of my students get a D. That's right here. I have a total of 90 students in my SRS, so that's 0.1 times 90 B. All right, so looking at our next question, number 6, if we want to compare the conditional distributions for preferred pizza brand among males to the same distribution for females, which of the following is an appropriate graph to use? Well, everything they did in the book. Side-by-side bar graphs. Now, I would argue with Mr. PhD on this one, but that's all right. We're going to stick with what they say. And next up, number 7. The appropriate null hypothesis. Ooh, that means we need to read carefully. Let's go back. Does it talk about one random sample? Bam. So there's just one SRS. Therefore, don't talk about proportions. Don't think goodness of fit. Think about independence or association. Appropriate for the null. Remember, that's independence, meaning there should be no association if we write it that way. So we've got gender and pizza preferences are, hey, that's nice. Look, boom. All right. Moving on to number 8. Are the conditions for a chi-square test of association independence met? Oh man, that gave away what we should have done for the one before. So if we read carefully, we should really know. And check your expected counts. Because they told us it's an SRS. It's reasonable to assume independence, so we really need to come back up and say, what are our expected counts? And we get 5.1. So far, so good. 7.9. Yes. 3.6. Ooh. What's going on with that? 5.4. 4.8. Something's up. 7.3. 5.5. And 8.5. Problem is, I have 8 numbers, 2 of which are less than 5. That's equal to 25%, so fail. We don't have greater than 80%. So which matches best with this? It's definitely not yes, okay, but no. And the reason is E. We do not have but 75% of our expected counts greater than or equal to 5, and we need to have 80%. For number 9, again, we're looking at whether it's homogeneity or independence, but then it says, which of the following statements is supported by the information on this table? Well, what did they give us? Oh, now we need to read carefully again. Individual components. Oh, wait a minute. They just gave us, when they say components, that is the O minus E squared over E values. I don't know what my observed are. I don't know what my expected are. So it says, which of the statements is supported? Chi-squared test statistic is 3.5. I don't know. You can't determine this without the original observed counts. Bam. Thank you. I need those original observed counts. I really, really, really do need them. All right. Lastly, number 10, we got some Canadians. They're hanging out with us today. All right, so what we need to do is calculate. We have H sub O is no association. Then I'm going to calculate a p-value. When I get that p-value, I end up with 0.87 by running my chi-squared two-way test. So that means don't pick this, don't pick this. My expected counts are big enough, so I'm good, so I can perform it, so don't pick this. What does it mean if my p-value is greater than any reasonable alpha level? That means that we think they're is no association. It supports H sub O. So which one of these says it supports no association or independence? C. That there is not enough evidence to show there is association. They messed with the wording for you. All right. So last thing we're going to do is I have a little diagram that we want to make sure that when you guys are thinking through which test is most important, what do I need to do? So we're going to do a little tree diagram. Remember that what we're dealing with is categorical data. All right, so we're looking at how do we differentiate what we're doing. First of all, we're talking about categorical data, so we need to decide, is it a one-way table or is it a two-way table? In a one-way table, we will only have one set of categories, which leads us to our chi-square goodness of fit test. If we have, on the other hand, a two-way table, we're going to have two full sets of categories with multiple mini categories within each of our main two sets of categories. But within our two-way tables, we need to decide, are we talking about the chi-square test of homogeneity, or are we talking about the chi-square test of independence? If it's independence, we're looking at one sample from one population with multiple categories. If we're talking about homogeneity, we're talking about two samples from quote-unquote two populations with multiple categories. Now, the key is for all of these, we're going to do basically the same process. For the test, number one, we want to calculate and show the expected counts. Okay, don't forget the two formulas for calculating expected counts. For number two, write the appropriate hypotheses, H sub O and H sub A. For number three, we're going to write all our conditions with a continuation statement. Then we're going to make sure we have all of our calculations. And we're going to have number five, our conclusion in context in two parts, whether we're rejecting or failing to reject H sub O and what that means in terms of the claim or the evidence presented. Don't forget chi-square CDF. You may need this. Lower bound, upper bound degrees of freedom. If I don't give you anything but a chi-square test statistic, this is what we need to use. And what if I ask you about which component contributes the most? Then we're looking at our individual O minus E quantity squared over E value. Hopefully this helps. Good luck with your test. Peace out.